All right. As yesterday, saving the last 25 minutes of class for us to do problems on the screen. And it can be from either today's review sheet or yesterday's, either one. Yes, Taylor? Number 26. And I just want to remind you guys that the test is closely aligned to the review. So if you can do every single problem on the review, then I don't see why you can't do well on the final. So it's also split to where like the first half is like the day one of the final and the second half is like the day two. So really close together. Anyway, so 26, it was kind of a weird problem. If you look at the pattern, is it like consistently adding? Is it consistently multiplying, or can you not really tell? I know that it's not consistently adding because when I go from 1 to 5, what's the difference there? And when I go from 5 to 17, what's the difference there? So it's not an arithmetic sequence. All right, so just kind of take that out of your mind. It's also not really a geometric sequence either, because it's not consistently multiplying the same thing to get the next number. All right, so when you see the problem like this, that's on your final. So it's like some weird patterns going on, but there is a pattern and they're giving you a rule. All right, all you need is that rule. And the rule is a recursive formula. I wouldn't necessarily say for geometric sequence, but it is a recursive formula because all the recursive formulas tell you to do is take the previous term and then if it's like an arithmetic sequence, add that common difference. Or if it's a geometric sequence, multiply that common ratio. Well, in this case, the rule is saying that we're taking the previous term, we're multiplying it by 3, then adding 2. All right, so this gives me the first 4 terms. It wants to know what's the 6th term for that sequence. So what do I need to find before I find my 6th term? I mean, I have 4 terms already, so I would need to find then my 5th term and then find my 6th term. Make sense? And that's what the recursive formulas are saying as well. Because if I want to find my 6th term, you plug in the 6 for the end. So the left side is just notation. When I plug it in, it looks like this: 3 times a sub 6 minus 1 plus 2. Which when you do 6 minus 1, what's that? 5. So what this is saying is I need to find my 5th term, multiply it by 3, then add it by 2. So we need to find the 5th term. So, and if you do that pattern, because what's 1 times 3? And then you add 2, what do you get? What's 5 times 3? You add 2, what do you get? Do 17 times 3, what do you get? Get higher. 17 times 3 is 51, and then you add 2, you get 53. So it is a consistent pattern. So find the 5th term. What's 53 times 3? What? 53 times 3? Yeah, 159. Is that what you said? Okay, it sounded like you said like 400 something. Okay, so 159, yes. And then add 2, what do you get? 161. All right, so that's my 5th term. That's what replaces the a sub 5 right there. Make sense? So then when we're looking for our 6th term, we have 3 times the 161 plus 2, and we get 485. All right, so it is kind of a weird problem, but just look at the rule. The recursive formulas tell you to take the previous term, multiply it by 3, add it by 2 in this one. It'll tell you a bunch of stuff, whatever it is on your final. Any other ones? Yes. 18. All right, so 18. Determine the domain and range of quadratic functions. And I know because it is a quadratic function, and either way, you should know how to do it for continuous graphs. So ones that are lines versus like discrete graphs where these are just points. So the domain for parabolas are always what? Let's take it back for a second. What does the domain always tell you about? The x's. What does the range always tell you about? And what's an easy way to remember that? Dr. XY. So when I'm looking at any graph, discrete is a little bit different than continuous. I'm looking for any boundaries on my x's. So does it look like that this graph will have a boundary on the x-axis, or does it look like it'll eventually touch all the x values? So again, the one on the right here. So look at your x-axis, look from left to right, all over the graph really, left to right. Does it look like it will touch all the x values eventually, or does it look like it just stops somewhere and doesn't continue on? We see how the more we go down, the wider it gets. These little arrows, that means it goes on infinitely. So if it keeps getting wider and wider, will it eventually touch all the x values? Yes. So my domain for this is all real numbers. There's no restriction on the x-axis in this one. For the range, so that's my y's. Does it look like it goes on infinitely up and down? No, it goes infinitely down, but not infinitely up. It stops right here. So for every boundary, you put an inequality symbol. So I have one boundary, so it's going to be one inequality symbol. We're going to use the letter y because it's our range. Range is for y's. And would you say that the y's on this line are greater or less than where it stops? So like it stops at the 6. It's less than. Does it touch the 6? Yes, so it's also equal to. All right, so y less than or equal to 6 describes all the y values on this line. Questions on this one? All right, let's talk about the one right next to it real quick because it is different. Would you say that these are like straight lines? No, they're separate points. So for this one on your test, you need to identify each point. So like, what's the coordinate of this one? -5, 2, good. What's the coordinate of this one? -2, 4. On the 4 on the y-axis. What's this one? 0, 5. So x, y always. This one is 2, 2. And this one down here is -3 and -3. So in the discrete graphs, you identify all your points. And then again, your domain is all your x's. For this one, it's just a list because it's not, every single point from -5 to +2. It's just the x's that are there. So it's -5, -2, 0, 2, and -3. If they tell you to order them a specific way, then order them a specific way. I don't know if it will. For the range, my range is 4, 2, 5. There's another 2, but do I write it again? No, you don't write repeats in your list, and then you have a -3. All right, so that's the difference, discrete versus continuous. Other questions? All right, yes, Leah? 20. Okay, so 20, you need to have a good understanding of vertex form. So that formula is right here in the blue. Well, I'm now highlighting it. So vertex form is another way to write your quadratic functions. And here, let me put the 2 that's supposed to be here. So a parentheses x minus h close parentheses squared plus k. When the formula is written in vertex form, it's really easy to see your vertex and your axis of symmetry. So your vertex is your HK, so whatever numbers are in the HK position. But keep in mind the H is always opposite of how it looks in the formula. K stays the same. And then you can also see your axis of symmetry really easily too. So your axis of symmetry is x equals the h of your vertex. So knowing that and given this equation, it's basically saying that my h value is what? So the h goes in the parentheses with the x, but notice it's normally minus h, but here it became plus. What had to be plugged in for that to happen? Well, if I plugged in a +2 into here, wouldn't it look like this? You're plugging in a +2. So it would be a -2 is what you plugged in. All right, and that's what we're showing right here. All right, because when I plug in a -2 into this formula, it becomes x minus -2. And what happens to that double negative? It turns into a positive. It turns into a positive. So that's why it looks positive here. So in other words, it's always, the h is always opposite of how it is in your equation. All right, the k will match up because it's a positive k here. If I plug in a negative, then it becomes negative. If I plug in a positive, it's still positive. So what this one is saying is sketch 2 possible graphs that could show a function in this form. Since they don't give you a value for k, all you need to make sure of is that it has the correct axis of symmetry, which is the -2. So like here's a couple examples that they. What number was it? 20? Here. So like you see how these are just examples. You could really do anything as long as the axis of symmetry is on the -2. So they both have vertexes with where the x is -2. The k is different because you can put whatever you want for the k for your example, but that's it. So on your test, it's like multiple choice. It may be asking about the x, it may be asking about the y. Just read it carefully and make sure that the graphs you pick match up with whatever the equation says. All right, which other ones? Yes, Sammy? 24. 24. All right, so 24. It gives you 2 different functions. One of them is graphed, so that's the g of x function, and the other one is an equation. So you need to be able to compare them. Like it might ask you, you know, which one has a higher vertex, which one, I don't know, what else they could ask you? Which one has a greater axis of symmetry? Things like that. So be able to identify it for both and compare. So like for the equation, how can I find the axis of symmetry? I can't use Desmos on the Galileo test, so you'll have to find it with the formula. What's the formula for axis of symmetry? Part of your quadratic formula, if that helps. So that's what it is in standard form. That doesn't help me identify my axis of symmetry though. Formula for axis of symmetry. Part of your quadratic form. Negative b over 2a. All right, that's your axis of symmetry formula. So maybe write that down if you didn't know that. Axis of symmetry formula. X equals negative b over 2a. So then when you look at your equation, what number is in the b position? Just the 6. Just the number that's in the b position. And then over 2 times a, what number is in the a position? Negative 1. So then simplify that. We get negative 6 over negative 2, which reduces to a positive 3. So that's my axis of symmetry for the equation. What's my axis of symmetry for the graph? That you shouldn't have to do any math. Good. It's at x equals 2. So it's the line that splits the graph so that it's symmetrical on both sides. So then x equals 2. That's my axis of symmetry for this one. You can just visually look at it. Now be able to identify the vertex. So because you found your axis of symmetry, you know that the x of your vertex for the equation is 3. And the x of your vertex for the graph is 2. How do you normally find the y for the equation? Plug in the x. So then anytime you plug stuff in, make sure you put parentheses. So the negative was already outside the x. When I plug it in, it looks like this. Negative 3 squared plus 6 times 3 minus 5. And you enter it just like that. If you don't put the parentheses, you get 2 different answers. You have to enter it just like that. And what do you get when you plug it in? Four. Thank you. So plug it in, you get 4. If you plug it in the wrong way, you get 22, and it's not. All right, now for the graph, you should be able to just identify the vertex by looking at it. What is the coordinate there? 2, 2, 9. So then compare them. Which one would have a higher vertex? The equation or the graph? The graph, because for the equation, it'd be like right here. All right. Do they both open the same direction? Like this one opens downward. What about this one? When it's a negative x squared, it opens downward. All right, so that's like a similarity. They both open downward. They have different axes of symmetry. They have different vertexes. Be able to say like which is higher, which is not. Questions? Do you need something? What do you need? So then, I don't know, turn it off, turn it back on, I don't know. All right. What else? Any others from the review sheet? Yes. 30. So this one, a sub n equals -40 times -2 times, or to the n minus 1. What's the value when n equals 3 and when n equals 6? So what do you think you're going to do with these numbers? Plug them in. So that's exactly what we did with the 3. We get a sub 3, which the left is just notation. Don't do anything to the left. It's saying the third term of that sequence is equal to this. So also notice I plugged in the 3 for the n. So this would be an example of a recursive formula, by the way, for the geometric sequences. So the ones where you have to like multiply each time to get the next number. And you know it's recursive because it has to the n minus 1. So yeah, you plug it in and make sure when you put it in your calculator, and you should just be able to type it in. Sorry, I don't know why I can't find this one. All right, when you type it in, either, and make sure you use parentheses around the negative. I don't know how many times I tell you guys to do that. If you don't do it, either do the 3 minus 1 in your head, or if you do want to put it all in at once, make sure that you put the parentheses around the 3 minus 1. Like that. All right, so either do the 3 minus 1 in your head and type it in. I feel like that would be easier for you than to try to remember that you need to have parentheses there. All right, but then that's literally all you're doing. Same with like the a sub 6. When n equals 6, you're just changing what n equals. So that's how we get the 1,208. All right, questions on 30? All right, I think that's all we have time for.